So, hello everyone. Yeah, so let's start. So, I will be solving questions for you because today I believe you've been taught what ordinary differential equations are and types of differential equations. You could also have been told about, um, you could also have been taught methods to solving different problems. You could have heard about linear differential equations, you know, non-linear. You also heard about maybe homogeneous, non-homogeneous. You've also heard about maybe somehow partial differential equations. Those are an aspect of differential equations. And most especially for you engineers, you will you will mostly work with um differential equations, but probably I think most times from my understanding and from my research, you mostly deal with partial differential equations. But if you don't know what ordinary differential equations entails, you might really struggle a lot with partial differential equations. So one of the things I also want to say is this. I know that some of you, maybe this is not your first time of solving this kind of problems, this and that. However, I will still need you to give me your concentrations because um, even if you could study on your own, sometimes just a single information could really help you to be much better. So for every one of us who had no understanding of what ordinary differential equations are, this is also a time to start from the basics, to grow and to learn together. Yeah. So let me start from uh, question. Let me call it 1A. So I don't need to differentiate that, define what differential equations are, because I believe that your professor has done wonderful work, handling those aspects. So I'm just going to solve problems just to prepare you for the class. So now let's start with problem one. Let me call it problem one. So problem one. Let me call it problem. Let me call it problem 1A. Let's say you are asked to solve. You're asked to solve 1 over x natural log x squared dx. So this is integration, just as we know and we've seen in our in our calculus classes. So in order to solve this problem, how do you think we go about it? What do you think we should look at? U-sub, thank you. Yes, the U-substitution. Because in order to be able to really solve this problem, it's not easily integrated or integrable, but just by using the U-substitution method, we are going to simplify the integration. So the U-sub is to make what looks hard or what looks big to become much more simpler and smaller. So let's solve this problem. Solution. Using substitution, using U-substitution method. Yeah. So we let what? Okay. Ln x, okay, equals to what? Let's call it U, maybe. Right. So that's good. So what's the next thing you think we should do? Since we said we should allow our natural log x to equal U, so just by use substitution, what do we do next? What is it? Exactly. So we solve for x. Yes, we might try to solve for x, but um, yes. But before we get there, uh, I think we should first differentiate. Let's differentiate. So we are differentiating with respect to what? X. Yes. It's okay. It's okay. We're learning together. Just get we are here to grow, to learn and better. So it's not so yes, we are differentiating with respect to x because we believe that x is the uh independent variable. So let's say for instance I say y equals 2x plus 5. So here I believe my y is depending on x. So that means my y is the dependent variable and my x is the independent variable. So whenever you are differentiating, you will be differentiating with the independent with respect to the independent variable. Do we not get that? So sometimes um, you might not necessarily be given a function of x. You might be given a different function. Let's say, for instance, instead of x here, I have, let's say, k here. So that means because I know that my k is the independent variable, I will be differentiating with respect to k. So that's just the basic idea. So now, since I know u is the independent variable, so I can x is the independent variable, sorry. So that means I need to find my u with respect to x. And this will give me what? 1 over x. Yes, 1 over x. You see that? So this simply means that um, I need to make x, the x subject of the formula. This is x du. Please make sure you're following also. So we have all we need. Now, returning back to the problem, I can easily say that integrate 1 over x multiplies with u squared, right? Do you see that? So because we use the u substitution, multiplies with the x will be what? X du. And so this means that I can I can divide through by x, and this gives us what? The integral of 1 over u squared du. Do you see how easy it is? So if we integrate 1 over u squared with respect to u, what do we have? Minus what? Exactly. Mm-hmm. Exactly, plus c. Yes. It's very important that you, whenever you are dealing with the indefinite integral, make sure you put the constant there. This is most common maybe when you're writing, when you're doing your quiz. If you're going to be graded on your quiz and you do not put C, you can be charged 1 point off. It's possible, but in exam it could be 2 points. So exams are always more intentional than quizzes. So I might still try to, oh, maybe your quiz, I might still try to say, okay, I think the student understands what he or she is doing, but exam, it's not like that. You need to know what you're doing in exam, please. So whenever you have this kind of integration, it is important that you had a constant there. It's called an arbitrary constant. So this is not where we stop. And finally, we have -1 over, what is our U? Yes, plus C. Final answer. So this means that your final solution must contain X, not U.